Hello, my name is Suraj, and today I'm excited to present my project on predicting a person's posture based on their personality. Now, body language is a key aspect of communication. We know that, and posture reveals a lot about a person's thoughts, emotions, and intentions. So, in this project, I use machine learning to develop a model that predicts a person's posture based on their personality type, which is calculated in this project using the MBTI test, which is Myers-Briggs type indicate test. Now, coming to the introduction, posture is the position and alignment of a body in response to the environment. So, good posture it helps reduce strain on our muscles and joints, and can also help prevent back pain and other muscle and skeletal issues. So, unfortunately, it's this is a very widespread issue. Like more than 70% of the population is predicted to be affected. So, this project aims to investigate the relationship between personality traits and posture, and whether we can predict like a person's posture based on their personality from the MBTI test. So, by understanding the link between these two, we can potentially develop interventions to improve posture and reduce the risk of back pain and other complications. So the MBTI test used in this project is Myers-Briggs Type Indicated Test, or MBTI for short. It's a personal assessment tool that has been uh, available since the early 20th century. It was developed in the early 20th century. So the test is based on the idea that people uh, experience the world through four primary functions: sensation, intuition, feeling, and thinking. So the functions are then combined with these two orientations, extroversions and introversion, E or I. Now, this test measures these four functions and two orientations to identify a person's personality type, which can help to better understand their behavior and preferences. So, there are 16 possible combinations of personality types. We can see in the picture, each represented by a four-letter code such as ENFP, which stands for extroverted, intuitive, uh, feeling, and perceiving, or ISTJ, which stands for introverted, sensing, thinking, and judging. So, while it is popular, it is important to note that it has been criticized for its validity and reliability, but it still remains a popular tool for self discovery and like understanding that like it can provide valuable insights into individuals preferences. Now coming to the data type, it only contains 97 rows and 20 columns, which is relatively less for a machine learning project. I have tried to find more data related to this topic, but I failed in doing so. uh, as you can see from the picture, which is an SNS heat map of the null values in the data set, there are no white spots, which means that there are no null values at all, which is a little helpful in this kind of data set, which is very short. Now, this is the overview of the data set. I'll be using the combination of age, height, weight, gender, activity level, and these MBTI values, not the this MBTI column. I used once in the logistic regression, but I'll talk about it later. And this posture column is the target variable for my model. Now, looking at the common distributions, the first picture shows us the bar graph of the female and male participants in the survey. They're almost equal. Now, looking at the distribution of posture types, which are four types: uh, A, B, C, and D. A being the ideal posture, and D being straight back posture. So A is better and D is the worst. So it gets from better to worse from A and D. From the bar graph, you can see that posture B is the most common occurring among the participants, and other postures A, D, and C are evenly distributed. Now, coming to the correlation among columns again, this is an SNS heat map of the correlation in of the columns in the data set. As you can see from the picture, like there's no significant correlation among the columns. This may suggest that there are no strong relationships between the variables, but it is important to note that correlation alone does not paint the whole picture. But there are uh, but there are other but like there may be some columns when combined with others can provide valuable insights and predictive power. Now, comparing posture with activity level. So there are three types of activity levels: high, low, and moderate. So as you can see from the graph, um, this is a pos- uh, posture score. So like if it's high, then the posture is worse, and if it's low, it's better. So as you can see from the graph, participants with uh, low activity level have the worst posture, and participants with high activity level have the better posture. Now coming to age, I created a new column which contains the age slabs. These are the age slabs, so that the visualization of the data is easier. When comparing posture with respect to age, participants in the ages 50 to 60 have the worst posture, as you can see, and they're followed by ages 40 to 50 and 70 to 80. Overall, we can see that older population has a worse posture, which is understandable. Now, coming to the height column, I made use of the slabs again. And looking at posture versus height graph over here, there's no well-defined trend in this chart. Now, this could be, or this is due to the fact that this data set is very small, but we can see overall trend that the posture gets worse with increase in height. Now coming to the classification, I made use of three classification models, which are logistic regression, decision tree, and gradient boosting. I performed logistic regression two times, one using the MBTI column and the other without using the MBTI column. So I assigned integer values to MBTI column with reference from a website, but the accuracy of the model was greater when MBTI column was not used, which is 55% compared to 40%. So this could be due to the fact that the assignment of the values was wrong. Now coming to the next classification, which is decision tree, uh, it contains I made use of categorical pipeline and encoder. In the pre-processing pipeline, this time I was able to achieve 60% accuracy, which is tad bit better than the logistic regression model. Now coming to gradient boosting technique, I made use of the same pipeline created for decision tree, and after using the gradient boosting technique, I got 60%, which is the same accuracy. Now coming to the conclusion, to conclude, even though the models have low accuracy, that may not be sufficient for certain applications. Uh, the precision, recall, and FN values are good, but the accuracy is not uh, high enough to be used in a real world scenario. So this just proves that there's a correlation between the posture and personality. Now it is important to understand, like as I told you again, the small size of the data set may have limited the ability of the model. This just shows that with larger data pool, we could theoretically predict the posture of a person based on their personality. Yeah. Thank you.